Every second, the universe is revealing information, not through light, not through images, but through motion itself. And sometimes motion is the only signal that remains when everything else disappears. When astronomers point telescopes toward the sky, they see stars, galaxies, and ancient light arriving from immense distances. But much of the universe does not emit light at all. There is no glow, no reflection, and no direct signal that any camera can capture. Yet gravity still operates there, silently and everywhere, shaping motion even in complete darkness. So how do scientists study something that cannot be seen, photographed, or directly detected? They do not search for images. They watch how visible matter responds. If an object bends, accelerates, or slowly drifts without explanation, then something unseen must be acting on it. In astronomy, motion is not secondary information. Motion itself is evidence. Galaxies are not static structures frozen in space. They move continuously through the universe, carried outward by cosmic expansion while simultaneously shaped by gravitational forces acting across vast distances. By measuring how fast a galaxy approaches or recedes, astronomers calculate its velocity with extraordinary precision. This measurement is not made by watching galaxies slide across the sky, but by analyzing their light. As objects move away, their light stretches, and its wavelength shifts toward the red end of the spectrum, a physical effect known as redshift that directly encodes motion. The greater the redshift, the faster the motion. Through this simple but powerful measurement, astronomers construct maps of motion that extend across millions and billions of light years, revealing how matter flows through space. But here lies an important limitation. Redshift explains expansion, but it does not explain direction. Yet galaxies near the Milky Way are not moving randomly through space. Their motion shows coordination. They are moving together. The most decisive evidence does not come from galaxies at all. It comes from the oldest light in the universe, the cosmic microwave background, a faint afterglow released when the universe first became transparent after the Big Bang. That ancient radiation fills all of space and arrives from every direction equally, forming a nearly perfect background. But this uniformity breaks if the observer is moving. One side of the sky appears slightly warmer, while the opposite side appears slightly cooler. This tiny asymmetry reveals our velocity through space, not relative to nearby stars or galaxies, but relative to the universe itself. It defines a cosmic frame of rest and allows motion to be measured absolutely. When astronomers trace that motion backward through space, it points toward a region rather than an object, a direction without an image. Nothing luminous lies at the center. There is no visible attractor. There is only influence. This is how astronomers measure the unobservable. They do not chase objects through space. They follow effects, correlations, and patterns that emerge only when many measurements are combined across enormous scales. As distance increases, light fades. Photons fall below detectability. Images fail. Yet motion persists. Positions continue to shift. Velocities remain measurable through consistent change over time, even when individual sources grow faint. By combining measurements from millions of galaxies, patterns become visible. Motion is not random. Galaxies follow gentle gradients embedded in space-time itself, shaped by gravity rather than by what can be seen. These flows do not lead toward visible targets. They do not end at objects or structures. Instead, they trace invisible contours of influence that define the architecture of the universe. In the universe, What we see is often secondary. Structure is defined by what cannot be detected directly, by curvature, by influence, and by motion acting quietly across cosmic time. And motion, patiently measured and carefully interpreted, remains our most reliable guide to understanding a universe that does not need to be seen to be known.